Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
This is Dianna Dini.
Hey, Dianna. Welcome to the show. I'm glad to have a chance to talk to you and get you involved with Speaking of Reliability.
Thank you. I'm happy to be here.
Great. I know that you have your own show, so we should plug that right off the bat. And
thanks for that.
Quality, I want to say, I always wonder if I should capitalize the during. Is quality during design or?
Yeah, that was just a getting fancy with the logo, with the uncapitalized middle word.
Okay.
But yes, it's quality during design, and that's the same as the website where you can find all the podcasts, and you can find them all on reliability.fm at Ascendo Reliability.
Oh, thank you. Thank you.
They've been a lot of fun to produce, and I've gotten some feedback that I've helped some people with some problems, and that's very exciting. That's why I'm doing it.
That's why you do it. Yeah, we don't really do these things for people to send us money. I haven't got that $100 million contract with Spotify.
No.
I don't think that's going to happen. No, that's cool. It's a good show. And I've learned a couple of things from it. And then there's one that came out this week, the week that we're recording on SIPOC. I don't know how to pronounce SIPOC.
That's how I say it.
Okay. So I have to go figure out what that is, because I've seen that acronym before, or abbreviation or whatever, and I have no idea what that is. So definitely have to listen to that one.
That's a supplier input process output customer. And the trick with this tool and with some of the other quality tools, even FMEA, is you don't pick up the template and fill it in from left to right, because that's just not how we think about things.
Right.
You kind of start in the middle and then work off to the end and then move over to the left a little. So that's one of the things I wanted to communicate with that episode. It's just these quality tools help you to reframe a problem, to think about it in a different way from a different viewpoint. And usually when you use them, you get an aha moment. So I walk through an example where we're trying to design a new bicycle pedal, and how we could use that SIPOC diagram of that process to help our team figure out what next steps should be. Oh,
excellent. Yeah. Now I got the teaser, so now I have to go listen to it. And I recommend everybody else go listen to it too. It's good. It's good stuff. Now, one of the reasons I wanted to get you on the show is to add another voice to it. So I'm very happy to have you on the show. And another one is it just happenstance came up today, and you were talking about these different tools and suppliers and all these things. So I think this is a perfect question that came in for us to chat about a little bit.
Okay.
So I got this email from Mohammed, and he says, I'm going through some interview preparations, and I'm curious if you have some materials that describes different reliability tests done to qualify modern smartphones. Now, if you're going to qualify a smartphone, I don't think it's just reliability tests. There's a lot more involved.
That's a complex device.
Right. But I mean, that's the question. And I did send him an answer back. So what do you think? How would you go about answering something like this?
I'm a bookworm. I would probably start with a textbook. But, as I'm thinking about it, there are some test houses. Now, a test house is someplace where you would send a device. They have what I call the shake, rattle, and roll test equipment. And they have videos online and some YouTube texts and other blogs that kind of describe what it is they do.
They describe what they can do, what their equipment does, not what you should do.
Right. So it sometimes in knowing what's available and what you could do can kind of help you what you should do. So it's always good to understand what's available and what the capabilities are of some of the best practices. But yes, you're right. A lot of reliability is in the test design itself.
Yeah, I've had a few of those that just don't turn out, and everybody's worried that their products failed. No, the test chamber failed, kind of thing. But no, I would back up from where the equipment is, or what ways you could go about evaluating it is what do you think of the idea of you got to know what you're looking for? What questions do you need to answer? I mean, because I think there's three different elements to qualifying something, not just the reliability part, but there's the regulatory stuff. Does it have the right emissions? Is it just transmitting the appropriate bandwidths? And is it not catching on fire? The safety kinds of regulatory type stuff, so you can even have it on the market. I don't think that's really qualification, but that could be in that bucket. Then there's
could be a deal breaker, right?
It could be. You got to do it. And unfortunately, different parts of the world have conflicting ones, so that's always a tricky one to solve. But how about the environment? Will it work in the environmental set of conditions where we want to put this thing? If you're selling it only in the Amazon, then high humidity and fungus growth and all those things may be important to you. Where if you're selling it only in, what's the snowy part of the country right now? Pretty much all of it. Will it survive the thermal cycling from going indoors to outdoors and, those kind of things? And then the third part is more the reliability, quality part of it is, does it do what you're saying it should do? Does it have X amount of battery life? Does the battery life sustain over time? Will you still get a full day charge after 2 years of use? But if you're going to end up with 4,000 things you need to go check really quick, and I don't think anybody's got the time or resources to do all of those checks that you can think of. So it's, how do you narrow that down? And so my thought is that you go back to, what does the team need to know? What are the risky areas? What are the parts that are uncertain? What do we need to learn?
And that's what I was thinking too when you're describing this. You got to look at the risk points and evaluate risk in an analysis so you can prioritize all these activities.
Sounds like FMEA, kind of.
Yeah, it sure does. Everybody cringes when we say that acronym, which is failure mode effects analysis.
Yeah. Well, that might be a subject for a whole nother conversation, because I am with you. It's like half the room just, I hate these. And the other, and it's what you mentioned at the opening on the SIPOC is there's an aha moment. And if you experience that when doing an FMEA, then you go, that was worth it. We need to do that more often. But so often it's just beat into you that fill out this form, do this part, do that part,
Yeah, it's a checkbox item, usually, which is a shame because it really is an analysis tool for people to make the best decisions that they can. You're not going to do an FMEA and get an answer. It's not a math problem.
That's right.
But right. It is a tool for people to be able to use to identify those high risk areas. You might find out that there is a design feature in your mobile phone that if it's not working right, the whole thing doesn't function, or
it's just
it blows up.
Point. Yeah, it would be bad.
Yeah, the really terrible things. So, or even if it's really happening all the time, if something breaks and then there's just an error that happens all the time.
Exactly. We don't want to know, was it MS-DOS 3.3? We don't want that again.
Yeah, no, that's going back a ways.
That's right. Yeah. But the idea, it go back to your comment about the checkbox kind of thing, is that I kind of got the impression that Mohammed was looking for, what is the checkbox? Is there a drop test, a moisture test? Is there a thermal cycling profile that replicates 4 years or 5 years of time? And the hard part about a smartphone, or pretty much any product these days, is that the standards and the regulatory people and the agencies that create methodologies of testing things are 5 years behind.
Yeah.
If we're lucky, they're 5 years behind of the technology and where the risks are. So it's really the FMEA. There's not a checklist to qualify a phone or any product is my opinion.
No, but those regulatory publications, even though they're 5 years behind, which I agree, they could be a good starting point. But then you do have to realize and keep in mind that there might be more modern methods or different kind of tests that could be performed.
Mm-hmm.
But at least you could start there.
Well, there's also very few people in the market today are creating a smartphone from scratch.
Yeah. There's a lot of history. Yep.
So it's like, what do you know? What do you don't know? What's failing in the past? What have you? What areas are at high risk that you missed that you don't have a test procedure for? That's the area we got to create a new one. Other areas that are marginal, let's do those again. Make sure you still are meeting the requirements. The other scenario I go through, I don't know if it's a tool or not, is what's new. It's sort of like the red flags. There's a new vendor. There's a new manufacturing process. There's a new material set in the product. There's a new innovation or design element that's never been used before. Anything new, I just kind of go focus on that. One, it's cool, usually. It's different.
Yeah. Yeah, that's true. Identifying new features, new components, because those are always unknowns, and you want to uncover the unknown. You don't want to.
Well, you could always assume it away and say, "Oh, it's the same form, fit, and function. It'll be fine." Like, no.
Yeah.
No.
Talking about what's changed, not just for the product itself, but also in the environment and how people are using it. Has changed. And with so much more technology, there's a lot of more integrations of different devices with mobile phones. The example I'm thinking of isn't with a mobile phone, but it was with another application in a medical device in a hospital. And it was a matter of when it was developed to interface with these kinds of equipment.
Mm-hmm.
But in 10 years, that equipment got revised and changed and was able to output things differently, maybe at higher pressures or different measurements. So it was a matter of evaluating the changes in the environment for where it's being used and then how it's being used with other things too.
Well, I'm thinking also of like the autonomous vehicle. The progression we're making to that is, it seems like every 6 months, the vehicles and different startups are coming out with systems that are trying to talk to each other or to sense each other. And that environment is just changing so fast. So if I remember reading an article where if every vehicle had a little transponder that says, I'm here, kind of thing, I'm going that way. Then the ability for cars to navigate on their own would be so much simpler. But how do you do that in the mix when we have humans driving some cars and other cars are on their own and some cars are in incompatible systems, and which one's going to win? And then trying to get a system to fit within that environment, knowing that it's going to change tomorrow. That is daunting.
Yeah.
Yeah. I got asked about a year or so ago, as a team is working on a LiDAR system, and it was pretty novel. It was pretty interesting LiDAR. Then I did a quick search, and there's like 118 companies, startups trying to make a LiDAR system, which is kind of a radar-ish. It's not using radar, but a different technology to sense the world about itself. And the idea is that they wanted to they said, we're going into trials. We need to qualify this product to make sure that it'll work through the trials. And I says, okay, well, how long is the product supposed to last? And he says, well, the trials last for 9 months. So it's really we want it to work for 9 months. Like, well, how long have you been using this thing? Well, we got one prototype working last week, kind of thing. And I'm like, okay, that's not as hard to do as opposed to eventually they're going to need it to work the life of the car.
Yeah.
Right? And do a 20-year type thing. And okay, well, here's a way to go about doing that. What's involved with where's this thing located and all those other criteria. And they started stepping through this. They says, well, we need to know all that for the qualification to sell it. We need to know what should we do to make sure it works for the trials. I said, well, pretty much the same thing. It's just different lengths of time. That's all. And there's vibration and a tree branch hitting it. And we just did a brainstorm of all the ways this thing could fail. And then they got into the manufacturing process. And I said, okay, maybe we should focus there. Because the alignment of these little cells was critical. And they didn't quite have ability to do that yet. So it's like, okay, well, let's focus on that first.
And there's an example of what we were talking about at the top here with FMEA. Maybe you didn't perform a full-blown FMEA, but you thought about all the ways it could fail and identified the critical pieces that they needed to focus on.
Well, part of that might just be me. I like talking about failures. I was just trying to understand the product. They sent me a schematic of it. And I'm like, well, I can read that, but it doesn't really answer the question of where's the weakness.
Right.
So it was really just a quick message grilling them about, and you could tell they were, even over the phone, they were getting uncomfortable. How come you're talking about all the ways this won't work? Well,
it sounds very pessimistic.
Yeah, it does.
Yeah. But it's really not.
No, I'm from the product boneyards, and I'm here to help. That's one way of talking.
Or I've heard you say the phrase before. We don't want to call your baby ugly.
Yeah.
Which always makes me laugh. Yeah.
And it's really hard to end the sentence there and not go, but there's, and it's tough. You've been there. You've gone into a risk assessment, or you're coming back from here's the set of gauntlets we want to run this product through. So we learn stuff, and here's the test profiles and stuff like that. And the poor designer is sitting over there with the prototype in his arms going, oh, I don't know if it can make that.
Or there's pushback because of the cost of doing the test.
Well, the smarter ones try to divert it to its budget,
Yeah.
Or we don't have time for that. We don't have budget for it. And,
yeah.
Yeah. That's probably the way not to do a qualification for a phone is wave your arms and say, oh, it'll be fine.
Yeah.
Just ship it. We got a big conference next month. We got to launch. That's probably not a good way to do it. I used to joke that or I probably still joke about it, is there's the Microsoft method. Have you heard about that method?
No, but I can take a guess, but why don't you tell me?
All right, well, yeah, ship it, and then, we'll patch it as we go.
That's what my guess is going to be. Go ahead and throw the beta out there and
That's
see
right.
what people think about it.
Well, even when they do a beta, a few years ago, they had 1 million beta participants, and they got inundated with tons. I mean, the operating system, any operating system, is amazingly complex and bazillion lines of code and all this stuff. There's so many ways it can go wrong, and there's so many things it has to interact with, right? So it's amazing any of them work at all. And I actually told that joke at Microsoft. I was at a meeting with them and says, well, we could always use the Microsoft method. Just ship it and we'll patch it as we go. And they all laughed, except for the guy that was my boss, basically. Because everybody knew it was true. And I says, to be fair, you guys do an amazing amount of stuff to make sure the product works. It's just that it's doubly amazingly complex. And your customers, a lot of times, really don't know what they're doing, myself included with Microsoft products. So but the qualification, to bring it back to that, whether it's a phone or anything else, is really got to match. Well, what do you need to know? It's if you run a test or if you run a measurement or an experiment, start with what you need to know. What's the question you're trying to answer? And what are those questions, and which ones are worthy of being answered? Which ones provide the most risk to you not shipping a product that's useful or works as expected or whatever? But there isn't a checklist and there shouldn't be, although there are some standards and some organizations that promote checklists. But I don't think that's the place to start.
No, that's the bare minimum. And it's not like you have to shoot from the hip with figuring out what do you need to know.
Right.
There are those analyses that you can perform with a team to help provide some direction to the team on what component's the most critical, or what is it we know from the previous version of this versus the new one. Yeah, it's not an engineer isolated trying to just pick something.
No. And maybe that's the checklist. Here's the types of questions you need to go answer, or the types of, FMEA and other types of tools to consider using. That might be the way to think of it. So if you're listening to this and, you're looking at, you're going to have to qualify something or get something shipped or know that it's meeting your requirements and all those kinds of steps, what's your process? Do you have a good one? That'd be really cool, Dianna. If somebody has, here's the checklist of things we do to figure out what we need to know to do. That would be cool if there's some of that stuff out there. But it's situational. Every product, every team, every market, every circumstance, every generation of your product is probably different. And so how do you deal with that? What's a process that's worked for you, or what's a process that needs improvement? Either way, let us know. We'd love to get you to be part of the conversation. And you can do that over at accendoreliability.com/go/SOR. And there's a widget to leave a voice message for us if you'd like to literally join the conversation on the show. Or there's a comments box. Dianna and I and the other hosts of the show are on LinkedIn, and we also have ways for you to get in touch with us on our About pages. So lots of ways for you to join the conversation, and we'd love to have you join us. So with that, I think we'll wrap it up here. Anything else, Dianna? Did we miss anything?
I don't think so. It's a big and complicated question with no one easy answer. But it's fascinating, and it's a lot of fun to do product design and figure out the reliability and quality of it. It's been it would be a good project working on a cellular phone.
Especially if you get to have one of them, if it works, That'd be cool. All right, cool. Thanks, Dianna, and welcome to Speaking of Reliability as one of the hosts, and look forward to talking to you again soon.
Thank you so much, Fred. Thanks for inviting me.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.